You notice we've not talked nearly as much about Uranus as we have about Saturn or Jupiter. That's because we don't know as much. Only one spacecraft, the Voyager 2 spacecraft, are the only ones that have actually been past Uranus. And so that makes it very difficult to say a whole lot, because the spacecraft was so far from the sun that it took a long time for radio signals to get from the spacecraft to Earth. We had to program where it was going to look long before the spacecraft got there. It looked, sent signals back. By the time they analyzed this and decided what would be cool to look at, the spacecraft was already past Uranus. And so that makes for a really difficult sort of way of studying these things. 27 known moons have been found around Uranus. Now, we expect there's probably a lot more than that, very small moons. Most of these are very small moons. So here's some of the biggest moons right there that are drawn to. And of course, I've already explained that some of these little small moons in close near the rings here are also acting as shepherd moons. So, as always, there's convention for how you name these things. So the moons here of Uranus are named after characters in the writings of Shakespeare and Pope, and hence like Juliet from like Romeo and Juliet, and Puck and Portia and Belinda, and those of y'all that are familiar with Shakespearean work, those are names that you've heard. All of the moons in the Uranus system are very dark. They have very low albedos. Umbriel, in fact, is the darkest moon in the solar system, an albedo of about 0.2. So most moons are nowhere near that dark. And so, so what's going on here? We believe the moons are a combination of rock and ice, probably more ice than rock. Remember, we're long ways from the sun. And a lot of them are interesting in how the water spectrum doesn't seem to match up. In other words, you look at the moons and parts of them reflect light, like from water ice, and parts of them don't. So that means there's some interesting sort of surface features on these moons. Umbriel, we have only a couple pictures of it. Only 20% of it has really been photographed sufficiently to figure out what it's like. And so this is like one of the best photographs right there, taken from the Voyager 2 spacecraft, using, again, early 1970s technology back in the 80s. And so what we find is that it's got a few craters in it, very shallow craters in there, that suggest the outer layer is soft, possibly icy, and that would suggest that in order to have the right kind of mass, the inner part must be kind of rocky. There's a very thin layer of organic regolith, and so what's going on here? Organic means it contains carbon. That's why it's so dark. It's black because of soot or graphite. So this carbon is coating it and other organic molecules. And so what's going on here? Well, likely what's happened is impacts have kicked a lot of stuff out. In other words, impacts have hit, this is out where comets fly around. They have a lot of organic molecules in them. They run into this moon, and those organic molecules settle on the outside. The other thing is, remember those clouds on Uranus itself. The color of the clouds is actually due to methane. We are so far from the sun that methane is a major component of things. And so the clouds are methane clouds. And so impacts into Uranus will create a big fireball which blows some of that methane out into space around Uranus. Well, wait a minute. What does that do? Well, methane is CH4, so it's a carbon with 4 hydrogens. Ultraviolet light from the sun breaks it down, and what you have is carbon with maybe a hydrogen or maybe not a hydrogen stuck to it, and that settles on the rings and the moons. That's part of what makes these things so dark, possibly. By looking at very, very tiny and very, very subtle variations in bright and dark, you can sort of make a map of the bright and dark parts of Umbriel, and that suggests that portions of it are dark and portions, there's regions here that are particularly dark with less dark regions in between. That suggests that, in fact, that there is some kind of resurfacing that has happened in here, that possibly cryovolcanism or something. So this is not necessarily a world that's been unaltered over time. Again, we only have a couple photographs of it, so we really can't say just a whole lot. Oberon, we have a little bit more views of because the spacecraft actually passed close enough to get a couple more pictures. About almost half of Oberon has been seen, and we do know that there's big chasms or big canyons that run across it. And so we think that possibly what happened was that it's got a small rocky core. The inner part is rock and ice, and the outer part is icy. It froze from the outside in, and so as the inside was freezing, ice expands, and that may have expanded and cracked the surface. Titania is the biggest of the moons around Uranus. It's the 8th biggest in the solar system. It's probably differentiated like the rest of the moons. It's got scarps and grabens. Again, the grabens are like canyons on here. The scarps, cracks, we're not really sure what caused those. There are some smooth plains in places on here. The smooth plains are believed to be possibly due to cryovolcanism. Again, not lava coming out, but frozen ice can melt and come out on the surface, or even at this distance from the sun, you can maybe have liquid methane squirting out on the surface and freezing. And so that could be another way of getting cryovolcanism. And so we don't really understand the geology of this moon. We have just a couple pictures, and all we're able to do is guess from those pictures as to what's happening. Ariel is weird. Ariel has massive chasms in it, canyons, scarps. It's got one of the brightest albedos of these moons out here. It's fairly evenly cratered, so there's craters on it all over the place, but not very many craters. It's very low density craters. That suggests that Ariel has resurfaced itself somehow. Possibly it is geologically active. Possibly tidal forces have heated it up and cryovolcanism has caused volcanic activity. Maybe not recently, but in the past this has happened. Again, we are guessing a whole lot about this. We don't really know a whole lot, but we look at it and say that's not what we expect this far from the sun, particularly around a world as boring as Uranus. We expect the moons to be boring, and yet this shows a considerable amount of geologic activity. And then they saw Miranda. And they thought we'd seen it all now. Then they saw Miranda and said, "Oh, this is like really takes the cake." It's got chunks, bright chunks which are like ice, okay, dark chunks that are rock, canyons in here, scarps, cliffs between the bright and the dark region, cliffs that are extremely high. It's almost like you just took a bunch of just random bits and slammed them together to make a moon right here. I mean, these scarps, cracks, canyons, I mean, they had never seen anything quite this dramatic. Again, you got rock and ice. Now, normally the ice floats to the top, the rock sinks to the middle. Here it's all jumbled together. This clearly does not make any sense. This is not at all what they had expected for any kind of moon. And so what's happened here? Well, an interesting idea they had was, what if it got reassembled? In other words, let's think about the asteroid Itokawa, which is just a pile of stuff. Remember we talked about Itokawa? It's just a pile of stuff. What would have happened if we had this moon out here and some really giant body had slammed into it, blasted it to pieces, and then gravity pulled all the parts together in one big jumbled pile? Then you might get something that looks like Miranda. So that's one idea. In fact, that's one of the first ideas they had about Miranda. And that seems to explain what we see. Now, a second alternative idea is that possibly Miranda's orbit might have been much more elliptical in the past than it is now, in which case tidal forces could have heated up the interior until it melted. And so the rock melting on the inside would have created massive melting for the icy layers on the outside, and uplifting and resurfacing would have occurred. Change in pressure could have caused big chunks of the interior to actually fragment and move around. And so there's some indication that may have happened. So we have these two competing ideas. One, that Miranda is the way it is because of a giant impact made it that way. And the other idea is it's the way it is because in the past tidal heating disrupted the interior and caused it to basically just kind of boil into this shape. Which one of them is correct? Well, we have no way of telling, really. Again, we got two ideas. The only way of testing these ideas is to analyze in greater detail Miranda. The problem is no spacecraft has been to Miranda since 1986. And so that means that we really don't know much else. So this is all speculation. You cannot see anything nearly in detail from the Hubble telescope or anything else. So we're just looking at this and taking our best guess. But it's been almost 35 years since a spacecraft has been here, and so and there's no plans really for sending anything anytime soon. So we are not really going to settle the question as to what happened to Miranda anytime soon. All we can do is look at these really old photographs from almost 35 years ago and take our best guess as to what happened.